So for section 2.2, the rules of differentiation. You guys know how like you always learn something in math and then a week later they're like, haha, there's a way shorter way of doing it. Guess what? We're doing that now. The differentiation that we were just doing with the x plus delta x stuff, there's a way shorter way of doing it. So for section 2.1, you're doing it the long way because that is deriving the slope function for the tangent. Man, that didn't come out right. You're doing it the long way. Now, with this, it's a shortcut to just get you answers. Okay? So we're going to go through a bunch of examples. The first example is called the constant rule. If you are trying to take the derivative of a constant number, so like derivative of 5. Nope. The derivative of 5 or any constant number is always 0. Always. And that would be because the constant graph is a horizontal line. So if I pick any point on that line, the tangent to that will be horizontal as well. The slope would be 0. So if you ever see the derivative of one number, you don't have to do that big long x limit x approaches delta x or delta x approaches 0 big thing. You can just say, oh, 0. Let's see. Question A, the derivative of 7. Do we need to go over it again?
No.
Okay, so let's participate. The derivative of 7 is?
0.
Oh, yay. Okay. Question B. If f of x equals 0, then f prime of x is 0. F prime of x is the derivative. If y equals 0, then dy over dx, which means the derivative, is 0. And then if g of t equals -3 over 2, then g prime of t is 0. Excellent. You just did 4 derivatives super fast. The next rule is the simple power rule. So the simple power rule would be if we have the derivative and then we take the derivative of a variable to an exponent. So I'm going to give you like a example over here. So let's say we do the derivative of x to the 5th. This says to take the n, which is 5, and put it in front. Then we take that 5 next to x, and we put x to the 5 minus 1 power. So 5x to the 4th. So the exponent goes to the front, becomes a coefficient, and then the exponent, subtract 1 from it. That is the derivative of x to the 5th. So instead of doing that big long limit, we can go straight to here. Because of this, if you are taking the derivative of just x, and I take that power of 1 and I put it in front, it becomes 1, and then I multiply it by x to the 1 minus 1. I get 1 times x to the 0, which is just 1. If you ever take the derivative of just the variable with no anything else, it's 1. Okay, so here's 4 examples. We're going to apply the power rule. Question A, f of x equals x to the 3rd. Then f prime of x is 3x to the 2nd. Done. B, y equals 1 over x squared. So they are telling us right now we need to change this to be x to the -2 so we can use the power rule. So the derivative of x to the -2 is going to be -2x to the should be to the -3 because we'll take -2 minus 1, which is -3. And then we will go ahead and change that back so it looks like the original. So we'll do -2 over x to the 3rd for the derivative for that one. Question C, g of t is t, so g prime of t is 1. If it's just the variable by itself, it's going to be 1. And then dr equals x to the fourth, so the derivative will be 4x to the third. Isn't that great? It's my favorite. So finding the slope of a graph. So we're going to find the slope of the graph of f of x equals x squared at 5 different places. So we know that graph f of x equals x squared is a parabola, vertex at 0, 0. Let's find the derivative of x, of f of x. What will the derivative be? 2x. 2x is the derivative. So now I'm going to take 2x and I'm going to plug in each of these x's. So I'm going to have my slope. You're asking for the slope, right? Yeah, the slope. I will do 2 times negative 2. I will do 2 times negative 1. 2 times 0. 2 times 1. And 2 times 2. And I'll have each of those slopes. So that's the slope at each of those points. So for this parabola that just sketched kind of bad there. For this parabola, at x is negative 2, the slope is negative 4 over 1. At x is negative 1, the slope is negative 2 over 1. I can't do that. Negative 2. It's not accurate. At x is 0, the slope is 0. That one you can definitely see. At 1, the slope is 2, so go up 2 over 1 to that point. And then at 2, it's 4. So I'm going to go down 4, back 1 to do it. So we've got all those slopes in there. Okay, the next rule is called the constant multiple rule. So this is saying we're going to use our, what was it called? Product rule, simple product rule? What's it called? Power rule. Sorry. Simple power rule. We're going to use a simple power rule, but there's going to be a constant with it. So this time we've got some number multiplied by f of x. So to do this kind, we are going to take the number out, and then we're going to find the derivative of f of x and just multiply them together. So here's an example. There's 2 examples right here. If I have the derivative of 5x squared, I'm going to first take out the 5 and find the derivative of x squared, because we just learned how to do that. So what's the derivative of x squared, which we just did in the example above it? 2x. So then I'm going to multiply that by 5, and I just get 10x as my derivative of 5x squared. For x squared divided by 5, I can pull out that divided by 5 as 1/5. And then do the derivative of x squared. So I'll have 1/5 times 2x, which is 2/5 x. So we're just going to do that multiplier like after you take the derivative. So differentiate the following functions for question A. I've got 2x to the 1/2, so I'm going to do 2, and then I'm going to do the derivative of x to the 1/2. And I'll just multiply by 2 afterwards. So what's the derivative of x to the 1/2? Where's the 1/2 go? In front, then x, and then what do we do the exponent? What do we do the exponent? -1. So what's 1/2 minus 1? -1/2. I'm just going to make this look a little bit better. 2 times 1/2 is 1. So x to the -1/2 would be like 1 over x to the 1/2, which we could rewrite as 1 over square root of x. We're not going to worry about rationalizing. Okay. So this one, we're going to take out the 4/5. And then we're going to do the derivative of t squared, so 2t. And then we'll multiply them together. Eight-fifths t. So you all are responsible for stopping me if there's a question you have. No? Example 5, applying the constant multiple rule. Question A, y equals -3/2 x. We're going to find the derivative of that. Philip, can you tell me the derivative of question A?
So the derivative would be, I mean, is it just x to the power of -3?
X to the what?
Power of -3.
Are you saying the answer?
No, I'm not.
I don't know what you're asking. Is what just the answer, just that? Or are you asking about the question? Are we not paying attention?
I've been paying attention.
Okay.
Sure, yeah.
So what's the first thing I should do here?
All right, so you have to look at logic.
What's the first thing I should do here?
Oh, you switch the x to the y or something.
No, you're not paying attention. Emily, can you help me? This is the easiest thing, Philip. Pay attention.
X to the -2/3.
No, what's the first thing we need to do? I just did it in like the last 5 examples. What's going on with this row column? Abigail, can you tell me?
Wouldn't it just be you take the one in front of it away and then x to the first, but then you subtract it, so it would be 1, so the answer is just -3/2.
Okay, so you lost me in your conversation because you weren't like being specific about what you were saying, but you have the right answer, so now I can follow you. You are correct. So she said, kind of said, to take out that -3/2 from the x, do the derivative of the x, which is just 1, and then multiply those together. That is the derivative of -3x over 2. Question B, Madeline. What is the answer? That is correct. And question C, Jack. That is correct. Pretty easy, huh? All right. Using parentheses when differentiating, find the derivatives of each function. So we're going to do the same thing. Before I take the derivative, so you'll see I still have y here, I'm just going to take out 5/2. And then I'll have 1 over x to the third. Maybe I'll zoom in a little bit here. But I'm not ready to differentiate yet because I don't want 1 over x to the third. So now I'm going to write it as 5/2 times x to the -3. So now I'm ready to differentiate. So Lainey, can you tell me what happens inside of the parentheses when I differentiate? What I get inside the parentheses? So there's no equal sign. We're going to differentiate. We're going to find the derivative. What happens, Gavin? Can you tell me what happens to this -3 when I differentiate? Goes to the front. And then what? We subtract 1 from what? It's going to be x to the power of, I think you said -4. So we're going to take away 1 from the power, from the previous power, that -3, we're going to take away 1. Okay, so that's where we're going to end up. And then I don't really like how it's written, so we're going to multiply together the 5/2 and the -3. And then we're going to put that x back down to the bottom. So we'll have y prime equals -15 over 2x to the 4th. That would be our derivative. If there's things you're missing here, please ask. Bless you. Question B. I'm not going to take the derivative yet. I'm just going to rewrite it. So now I have 5 over 8x to the 3rd. So you got rid of those parentheses. Following? I'm going to rewrite it as y equals 5/8 times x to the -3. So I moved that x up. So now we can take the derivative. Barry, can you help me?
With the whole, okay, it'd be 5/8 and then parentheses -3x to the -4.
So we'll take the derivative of just the x to the -3, and then we'll multiply stuff back together. Oops, and I forgot to write my my prime. So I get -15 over 8x to the 4th. Question C. Sam, am I ready to start like finding the derivative right away? Okay, what should I do first? Okay. Okay, so we're going to factor out the 7/3 and just move x squared. So now it's in the numerator. Now can we take the derivative? Okay. So I'm going to take the derivative. And Marie, can you tell me what we get? So in between those two, what did you do to get 14 over 3x? There's people that don't know what's going on, so I want to make sure everybody sees how to get there. Okay. Good. So you took the derivative of x squared, and then we multiplied it by 7/3. Okay, the fourth one. Abby, am I ready to start finding the derivative right away? Okay, what should I do first? Okay, so I'll have 7 multiplied by 3x to the second. Peyton, should I go ahead and take the derivative now?
Or no, you gotta factor out the squared. So it'd be 7 times 9x squared.
Okay,
And then now you can.
okay. So now I can take the derivative. And Tyler, what will my next step kind of look like?
3x squared.
Well, that's kind of this step here. What will my next step be? Do you see I put a little prime there? So I'm actually going to do the derivative.
Isn't that just 2x?
Mm-hmm. So I'll have 63 times 2x, which is 126x. Right? Did I do my math right? Patrick, I'm going to take the derivative of this question here. You're going to help me. What should I do first? So x to the, say it again. Okay. X to the half. Is that the derivative or? No. We're just rewriting it so we can have it in the power form. And then what we're going to do, Patrick? Okay. So we are going to do the derivative. Sanjay, can you help? So it's the exact same thing I've done like the past 20 examples. Emily, you can help now? Yep. So we're going to take the derivative, which means we're going to take this power, we're going to put it in front, and then we're going to subtract 1 from the exponent. That's what I've done every single time. So now I'm just going to rewrite this so it looks somewhat like our original. So the derivative, or y prime, equals, looks like 1 over 2 square root x. Is that right? Yeah. How about b? Gracie, are we ready to take the derivative right now? So what should I do to make it?
I changed it to 1 over 2 and then x to the 2.
Okay, so we're going to change the radicals into rational exponents. You're going to make radicals into rational exponents. We want powers. And then from here, I'm still not ready to differentiate. Eden, what should I do now?
I took out the 1/2.
Okay, so you took out the 1/2. Am I ready to differentiate? Okay. Who have I not bothered? Philip, come back to you. Am I ready to do the derivative? And it's not derivatize, it's differentiate. That's the correct form.
What was the question?
What do I do next is the question.
Yeah. So you want to take the 2/3. You see that?
Mm-hmm.
You know, put it, I don't know, put it in front.
Not yet. Not ready.
Oh, I see. You want to.
Okay, I'm going to come back to you because you're almost there. Christopher, can you tell me what to do?
Oh, so that's what x is first of all. So 1/2 times x to the negative 2/3.
Okay, so 1/2 x to the negative 2/3 gets it out of the bottom. Now going back to Philip. Now what should I do?
Put it in front.
Hmm?
Put it like in front of x.
Put what in front?
Take the negative 2/3.
Negative 2/3.
Put it in front of the x.
Put it in front of the x. And is that it?
Of course not. Is it?
So then finish.
Only a fool would say that's it. Oh yeah. You like took the what's it called? Yeah. You subtract one
From the,
of the exponent.
okay, so we're going to subtract 1. So what's my new exponent?
Wait. Oh, it's 1 from the negative 2/3. Oh, it's negative 5 over 3.
Negative 5 over 3. Okay. So that's the derivative, but we're going to simplify it and clean it up a little bit. Okay. So I'm just going to finish this one here. So I'm going to multiply those together and I'm going to get negative 1/3. And then this will be 1 over x to the 5/3. So could be like 1 over 3 x to the 5/3. It could be like 3 cube root of x to the 5th, or it could be 3x cube root x squared down there. I'm just not going to rationalize it, okay? And I'm not going to do the last example either. We're just keep moving on. There's one more kind that we're going to learn the rule for, and that's sum and difference. So sum and difference would be like this example that it says differentiate y equals 3x plus 2x cubed. Sum and difference would be if we have a function plus another function, and we're trying to take the derivative of all of that. So it's like a polynomial. So if I have a function of 3x and a function of 2x cubed, to take the derivative of that, you just take the derivative of each piece separately and leave the sign in between. Okay? So the differentiate y equals 3x plus 2x cubed, I'm going to, oopsies. I don't know how that happened. I'm going to get y equals, and then we're going to differentiate 3x. And Sam, what will the derivative of 3x be? 3, good. Plus, and Ryan, what would be the derivative of 2x cubed? Close. So multiply them together. Okay, I'm just doing that part in my head, so. So that's the derivative. Oops, I didn't put the derivative mark. There's the derivative of y. Using the sum and difference rules, find the slope of the graph of f of x equals x cubed minus 4x plus 2 at the point 1, negative 1. So the first thing I'm going to do is find the derivative of that equation. Megan, can you help me with the derivative? Yep, that's right. Fine. Yeah. So minus 4x becomes just minus 4, and then plus 2 is 0. So we don't have to write anything for that. So that's our derivative. Now find the slope of the graph at the point 1, negative 1. So what am I going to do to find the slope at that point? Plug in what? The whole coordinate? Just the x. So we'll do f prime of 1. So 3 times 1 squared minus 4, so -1. So my slope at that point is -1. That is not the y value here. That's coincident. This is the slope. The y value is in ordered pair. Okay, one more. Using the sum and difference rules, find the equation of the tangent line to the graph of g of x at the point -1, -3/2. So the first thing we need to do is find the derivative of g of x. Sanjay, first term. What's the derivative of the first term? Good. -2x to the third. Patrick, what's the derivative of the second term? So what is that something? No. No. You take 3 and you go in front and you multiply it by the number that's sitting there. 9. And then Jack, what is the derivative of the third term? Yep. So that is our slope formula or derivative. So we're going to put in x equals -1. And I get my slope is 9. So now we're going to write the equation of the line that is tangent at that point. So we have the slope. We have a point. What are we going to do? Point slope form. Okay, so I get the equation of the line is y equals 9x plus 15 halves, so plus 7.5. Okay, so that's it for section 2-2.